Okay, let's get started. So I'd like to welcome you guys to this Web Speaks webinar series. So before we continue, I would like to ask you guys to raise your hand in Zoom software. This way I can verify you can hear me. Thank you, appreciate it. Okay, so my name is Faheem. I'm a Microsoft certified trainer. I'll be covering this particular session. So today's agenda is So basically, the title of the webinar is continuously deploying your web applications with Microsoft Azure DevOps. And the agenda is we will first of all talk about what exactly DevOps is. Then we will talk about how we can use source control management. In particular, we will talk about Git. We will use Git in Azure DevOps. And then after that, we will discuss what is continuous integration. In short, we call it CI. Then after that, we'll talk about continuous deployment, which is the main scope of this webinar, like how we can continuously deploy our web application to Azure environment. And lastly, we'll talk about Docker containers, because when it comes to deployment, as far as this particular session is concerned, we will mostly focus on how we can create a Docker container, which will contain our custom web application, and our container will basically be deployed to Azure. Otherwise, Azure does support other techniques as well when it comes to deploying your applications. For example, you can use a virtual machine, you can use Kubernetes, there are other techniques as well. But in this session, since it's a fairly short session, so we can only cover so many topics. So our main focus will be to see how we can containerize our web application and how we can continuously build our application and continuously deploy our application to Azure environment. And then before we continue, our one small request. I have a fairly horrible sore throat. I'll do my best to speak as loud and clear as possible. If you have any issues, just let me know. And also feel free to send questions in the chat window of this Zoom software. I'll answer them when it's appropriate. And the format of this webinar will be, first of all, I'll talk about some of the important concepts, and I'll show you quite a few demos as well. Most of the demos will be pretty much end-to-end demos. I'll show you how we can set up pretty much everything from scratch. But keep in mind that it's a fairly short session, so we will only focus on just this particular aspect, which is how we can build a basic web application and how we can deploy it to Azure, especially by containerizing it. Otherwise, we do have full-blown course or courses available where we cover more advanced topics as well, which I'll talk about at the end of this session. Okay, so before we continue with this session, I'd like to ask you guys to answer a couple of simple questions, like do you guys already have DevOps implemented at work at this point? If yes, do you guys use any specific tool sets? Like, do you guys use Jenkins, or are you guys already using Azure as well, and so on? So basically, the two main questions are you using DevOps? And if yes, then what tool sets are you currently utilizing? Are you using Jenkins, or are you guys already utilizing Azure? Thank you, appreciate it. Okay, so some of you guys are using DevOps. Most of you are not currently using DevOps. A couple of guys are using Jenkins. Okay, so I'll talk about a bit of Jenkins as well, but our main focus will be on Azure DevOps itself. Okay, so for those guys who haven't utilized DevOps in the past, DevOps is basically a combination of development and operations. So it's basically an agile sort of methodology, which is not just focusing on development process, but it also focuses on operations side as well. So usually when we follow agile methodology like Scrum or extreme programming, etc., and so on, we mostly used to focus on just the development part. Like, we used to analyze the project, we used to start development, we used to test the project, and that is it. But DevOps includes operations as well, which means that once you're done with the development, we should be able to deploy it as well. And that is exactly what we will discuss in this session, practically, like how we can develop uh, any type of application. Our main focus will be to take some case study sort of application. Like here, I'll take a .NET Core application, but you can definitely choose to utilize Java with Spring Boot, or you can use Node.js, or pretty much any other uh, development technology as well if you want. So basically, we will see how we can develop an application and how we can deploy it as well. That will be ready for use, basically. So basically, DevOps is a combination of process, culture. It also suggests some tools as well, and it also heavily focuses on automation as well. So it's an end-to-end process, basically, which includes lots of things. Like, it's not just the development part. In just a bit, I'll talk about some more things as well that are involved in a typical DevOps process. So usually it includes planning, development, testing, deployment, etc. Pretty much the whole thing is included, basically. So even in this diagram, you can see that usually we write some code, or even for that we plan something. We write the code for it, we build it, we test it, we release it, which means that we are approving some build, and then we are going to deploy it to some environment, and then we monitor the application, and we just rinse and repeat. We go back to the whiteboard, we develop more bits and pieces of the application, we build it again, we test it, we deploy it, etc., and so on. So it's an end-to-end process, and it's a continuous process, which means that unlike waterfall methodology, where we usually just develop the application, it can take several months or even years and so on. And after that, usually we are done. We just provide bug fixes, etc., and so on. Here, it will be a never-ending process. So we'll keep on writing more code. We will keep on building it. We will keep on deploying it, and so on. So it's an end-to-end process, basically. And culture-wise, it involves pretty much all major roles, like analysts will be there, architects will be there, developers, testers, and even operations team will be there as well, so that they can make sure that the build is stable and it's always functional, etc., and so on. And it heavily focuses on automation aspect as well. So automation wise, if you don't implement or use automation, you will basically have to write some code, you will have to click some button to build your application, then you will have to click some other button to run some unit tests or other types of tests like integration tests, etc., and so on. And then you will have to click a few other buttons to deploy the application, etc., and so on. So rather than clicking so many buttons, we want to automate this overall end-to-end process. So in just a bit, I'll talk about it in more detail, and you will see it practically as well. You will notice that we will write some code. We will check in the code to some repository. Here we will take a Git repository, and the moment you check in the code, it will trigger a build automatically. So the application will be built and it will be deployed to Azure automatically. So basically, on day-to-day basis, you will just be responsible for writing the code, and the end result will be your application will be deployed to Azure. It will be fully functional. So automation is usually also fairly important in DevOps. And definitely, DevOps recommends some tools as well that we should use so that we can fine-tune or make sure that the whole process is optimized and so on. So tools-wise, here we will definitely utilize Azure-specific tools. Otherwise, depending on what other cloud platform you're using, or if you're using on-premises sort of environment, then in that case, you can use different tools and so on. So here we will mostly focus on Azure-specific way of implementing DevOps. And DevOps, like I mentioned, that it's actually the end-to-end process as well, in addition to involving all possible roles, automation tools, and so on. So process-wise, we basically start off with planning. So you always plan your project first. Like if you're already using agile methodology like Scrum or extreme programming and so on, you must have seen that we usually come up with a product backlog. In the backlog, we add product backlog items. And each PBI, product backlog item, is either an issue or an epic or a task. And then we find all these tasks, we assign these tasks to the developers or to other team members, and they work on those tasks, they complete the tasks, and so on. So basically, planning is definitely very important. So we plan our project, and then we start writing some code. So whatever code you write, ideally, the code should be checked into some repository, like Git, or you can just use SVN or a TFS specific version control solution like TFVC can be used as well if you want. But in short, you should check in the code to some repository, and you should build the code based on whatever code you have in the repository that should be built basically. So continuous integration means you write your code and you build it. And ideally, it should be automated. So the moment you write some code and you check in the code to your Git repository, the build process should start off right away, ideally. So that's basically automation in practice. So continuous integration is all about ensuring that the moment you write the code, it should be checked out of the Git repository or whatever repository you have. You should build it, and then we should also run some unit tests as well and so on. Usually that is done as part of quality, but you can also involve it in the continuous integration process as well. And before I continue with the rest of the steps, so version control wise, are you guys using any version control right now? Like Git or TFVC, Team Foundation Version Control, or SVN or CVS? Okay, awesome, thank you. So most of you are using Git, some of you are using Bitbucket, a few of you guys are using TFS specific version control as well, which is TFVC. Okay, so good thing is that all of these are supported by Azure DevOps. So I'll talk about Azure DevOps in more detail in just a bit. I'll show you that practically as well. But most of these version control solutions are supported by Azure. But definitely Git is the industry standard these days because it's a distributed version control. It has lots of bells and whistles that are not usually there in other version control solutions, but it's still okay to use any other version control solution as well. Okay, so basically continuous integration, in short, we also call it CI, and you write your code, you check in the code into your Git repository, and the moment you check in the code, it should be checked out and it should be compiled or built basically, and then we should run some unit tests, etc., and so on as well. And after that, usually in real world, we also check for code quality in more detail. So code quality wise, we use various concepts like static code analysis. Static code analysis basically goes over our code and it recommends some pitfalls, like some potential issues that could be there in our code. Like, is the code maintainable in the long run? Will you be able to maintain the code? Like maybe you have written way too many lines of code in each function, or you have very few files or very few classes, or you're not using design patterns, etc., and so on. Or if you're writing code in a bad manner, like if you have hard-coded SQL queries, you're not using parameterized queries or calling stored procedures, etc., and so on, that can cause security issues. So code quality can basically be very important. We should check for it as part of our overall build process or as part of our overall end-to-end process, so that we can ensure that we deploy the best possible quality of our code and so on. So I'll talk about this to some extent later on. Like we can use Sonar Cube if you're using on-premises environment. Otherwise, if you're using Azure or any cloud environment, you can use Sonar Cloud. You can use Ndepends, there are quite a few other options as well, which I'll talk about later on at the end of this session. So basically, you build your code and you check for the code quality, you ensure that your build is of high quality, and then you deploy it. So deployment wise, I'll talk about various options in detail later on, like you can choose to deploy your application to a virtual machine, or it can be a Docker container, or it can be Kubernetes environment. If you're using Docker container, you can choose to extend it by involving Kubernetes as well. So I'll talk about that in detail later on. And usually we use a short term for it. We call it CD. CD can mean two things. So CD can be continuous deployment, or it can also be continuous delivery. And there is a difference. So they're not synonym or synonymous sort of terms. There is a difference. And the difference is that in case of continuous deployment, you deploy your application that you have built as it is right away, with no manual approval involved. So in case of continuous deployment, the moment you build your application, you test it, you just deploy it right away. Whereas in case of continuous delivery, we involve manual feedback. So we wait for some person to approve our build. So it also sort of means that you will have to click some button or some hyperlink to promote the build to the next environment, basically. So continuous delivery usually involves manual feedback, and upon approval, it will be deployed to whatever environment you want. Like in complex scenarios, usually we have dev environment, we have test environment, we have system integration test environment, SIT, we have user acceptance test environment, UAT, we have production environment, etc. and so on. So we can have lots of environments. So in case if you are deploying your application right away without any manual approval, that is continuous deployment. Whereas if you are waiting for some person to approve the build before you promote it to the next environment, that is continuous delivery. So here in this particular session, I'll mostly talk about continuous deployment. I'll show you this practically as well, but keep in mind that we can also choose to get some feedback, so that some person should receive some email notification with some link to some application. The person should test out the application and approve the build by clicking some hyperlink or some button, so that we can promote it to the next environment and so on. And then once we have deployed our application, we should monitor our application. So monitoring would mean you check for the CPU consumption, the RAM consumption, your storage, etc. and so on. Ensure that the application performance is top-notch. It's meeting all the specifications or the requirements, the functional requirements, and so on. And it also means that if your application has too much load on it, then we should ideally implement load balancing, so that we can distribute the load. So rather than redirecting all the traffic to just a single process or to a single instance of our application, we should divert the load to other instances, so that we can have better performance and so on. And monitoring wise, we can also implement failover or automatic failover, so that if we have multiple identical instances of our application running, and if one of the instances has crashed, then we should redirect the traffic to some other instance that is still up and running. So basically, continuous monitoring ensures that our application is always up and running, and performance-wise, it's giving us the top-notch performance that we expect and so on. And then usually we also get some feedback from various stakeholders as well, like the users, etc. and so on, even the developers, and pretty much all possible roles, so that we can fine-tune our overall DevOps process and so on. So basically, DevOps is a continuous everything type of process, which means that everything is continuously performed. We continuously plan our project. We continuously write some source code. We check in the source code into our Git repository or whatever repository we have. We build our application, we test our application, we ensure that the application is of high quality, that we deploy it, we monitor it, we keep on improving our process, etc., and so on. So basically, it's a never-ending, continuous process. That is basically DevOps in a nutshell. And you can see that it does involve pretty much all possible roles. So planning will mean your managers will be involved, your architects will be involved, your analysts will be involved, integration-wise, developers will be involved, to some extent, testers will be involved. Otherwise, testers will definitely be involved when we implement continuous quality, then operations will be involved as well, and so on. So basically, it's a combination of development and operations. Okay, any questions so far regarding DevOps, continuous everything concept? Okay, so keeping this in mind that DevOps is a continuous process which involves lots of things like planning, etc., and so on. Before I show you some of these things practically, let me first of all give you a brief overview of continuous integration, and then after that I'll show you some demos like how we can get up and running with Azure DevOps to set up our DevOps process on Azure Cloud, how we can check in our source code, how we can perform various operations, and so on. So before I show you things practically, let me talk about this continuous integration in slightly more detail. So if you recall, I did talk about it previously as well, that usually on day-to-day basis, you will plan the project, you will come up with sufficient user stories or backlog items for the current sprint, and each sprint is usually 2 to 4 week sort of long cycle, and whatever items you have identified for the sprint, you will write source code for it, and you will check in the code into your repository. Like it can be a Git or TFVC or Bitbucket, etc., and so on. And ideally, the moment you check in any code into your repository, we should check out the code from the repository automatically, and we should build it. And then after that, we should test it, and the whole process should ideally be automated. So on day-to-day basis, a developer should only be responsible for writing the source code and check in the changes to the repository. And everything else should happen automatically. So here I'll slowly and gradually show you a demo. It will discuss all these things practically, like how we can set up our Git repository, how we can check in the changes, how we can ensure that the build is performed automatically, and so on. And why we should implement continuous integration? Obviously, due to automation, there will be less chances of having human errors. And the quality of our application will be high since we are not going to skip any test or any step. So we'll always have a very consistent process. And ideally, we should involve tests as well, like unit tests or integration tests, etc., and so on. And it does reduce the overall build time as well, since you're going to automate things. So the moment the code is checked in, a build request will be queued up, and it will build our application automatically. So this way, we can avoid having any human errors, etc., and so on. And since we are going to involve unit tests and other types of tests as well, so it will ensure that the code will be of high quality, or the build will be of high quality, so that you can deploy it to your environment and have more confidence in your application and so on. So I'll talk about some of these things in more detail later on as well. Before that, since we are already aware of some of the core basics, let me show you a quick demo, like how we can set up a Git repository. So those guys who have already used Git in the past, well and good. Those guys who haven't, I'll give you a quick overview of Git. Initially, I'll show you how we can use Git on a local machine. After that, I'll show you how we can set up Git on Azure. And then I'll show you how to clone that Git repository and so on. So usually when we set up a repository by using Git, which is a very popular version control solution, we usually set up our central repository, which is also known as a remote repository, and we also create a cloned copy of it as well. So what does that mean? Let me actually explain that in more detail here. So say we have this central server. So this is available as part of your organization, and you have your source control repository like Git set up here. And the rest of the developers will use their own local machine. So all these developers will basically connect to this central repository, and they will create a cloned copy of it. So this is your central repository. In short, we can just call it remote repository. That's the more official name used in Git as well. It's a remote repository. And on the developer specific machine, here we'll create a cloned copy of it. So a clone is basically the identical replica of this remote repository. And on day-to-day basis, developers will make changes on the local machine, and they will commit changes just on the local machine-based repository or this cloned repository. But once they are done writing the code and they have confidence in their code that yes, they are ready to share it with the rest of the developers, they commit the changes into this remote repository. It is also known as push process. So basically, push means you push the contents of your local repository into the remote repository so that the rest of the developers can see the changes of this remote repository on Azure. So for Azure, I'm already logged in here. And then here, if you want to set up a Git repository directly on Azure, you can search for Azure DevOps. And when you go to Azure DevOps, so that you can set up your entire end-to-end process, like it should have a Git repository, we should be able to implement our continuous integration pipeline so that we can build our application by connecting to our Git repository, check out the code and so on. And then we should also be able to deploy our application as well. The fourth step would be once you go to this Azure DevOps, you should set up an organization on Azure. And what's the meaning of organization? Organization basically means that it's a collection of projects. So for example, if you are working on a very complex project like ERP, Enterprise Resource Planning, you will have sales, marketing, inventory, general ledger, payroll, accounts, etc., and so on. So you'll have lots of sort of sub-projects basically. So in order to organize these projects together, you'll want to create an organization first of all. So here I do have some organizations. I'll not use any of these organizations since I want to show you a demo from end to end. So I'll create a new organization here. So just go to Azure DevOps, go to this manage organizations option, create a new organization. It will just ask you to give it permission so that it can read your account profile. Since you're the sort of the owner or the administrator of Azure in this particular case, so it's okay to allow it. And then I'm going to create a new organization. Let's say I'll just call it ERP, whatever name you want to use here. Specify where you want to create it. You have to specify some region. So region-wise, I'll just use this Canada Central for now. Apparently, this one is already in use. I'll just add some other suffix to it just to make it unique. So basically, Azure DevOps, when you create an organization, it will later on let you create projects. And each project can potentially have its own separate Git repository. So once you are done creating this organization, next it will ask you to create a project. And notice that it does send you email notifications as well when things are done. Like later on, when I perform the build process, you will notice that I'll be receiving quite a few email notifications. You can turn them off if you want. So once we are done creating this organization, we have ERP 2020-01. Let's create a project here. I'll just call it, let's say, sales project. You can choose to make your project private so that only the authorized users should be able to see this project, which is a best practice. Otherwise, if you are working on some open source type of project and other people should be able to see it as well, you can choose to make it public if you want. So for now, let's just keep it private. Create project. So your organization should have at least one project. So like I mentioned that ERP, Enterprise Resource Planning, can have, let's say, sales, marketing, general ledger, payroll, accounts, etc., and so on. For now, I just have one. And here, before you start creating your Git repository right away, let me also briefly talk about this boards option as well. So since Azure DevOps, it does let us implement the entire DevOps process, which means that we can implement continuous planning. We can plan our project, we can integrate it continuously, we can deploy it continuously, and so on. So planning-wise, it does provide us with this boards option, where you can add work items, or you can maintain your backlog items. You can organize them in the form of sprints, etc., and so on. So let me give you a quick overview of this boards option as well. So if I go to this boards here, you can go to this, let's say, backlogs. We can add some issues or tasks here, and then we can see how the board will look like. So let's add a work item here. You can also choose to create multiple sprints here. For now, just one sprint is okay here. So let's add an issue here. So let's say we have create Git repo on Azure. Let's add more here. Test, check in, or commit process. Then create a .NET Core application, and then push changes to Azure repository. So you can add as many tasks as or issues as you want. You can add epics. You can break down epics into smaller issues or tasks, etc., and so on. You can assign these to multiple users as well. For now, we have just one user account, but in real world, you can add multiple user accounts. You can assign them permission to this project, and you can assign these issues to various users and so on. And if you go to this boards here, it will show you these issues, and you can add them to your doing and done sort of columns. You can customize these if you want. You can add more columns as well if you want. So for now, let's say that we are going to create a Git repository on Azure. We are actually pretty much done with it. We just have to go to repos, and then we just have to see how to add some credentials and how we can create a cloned copy of it and so on. So let's say for now, I'm just moving this particular task to this doing column. And then next, let's look at Git repository here, which is what I was trying to show you previously on my local machine. But since we will be doing pretty much everything on Azure and by following the best practices, so let me just show you on Azure right away, rather than showing you anything on my local machine. Okay, so here, once you go to this repos, it will show you this files option. Before you access any file, just make sure that you click this repos only. It will show you the URL to your repository. And before you access this particular URL, you should generate Git credentials so that only the authorized users should be able to connect to this particular Git repository. It will use this username, which is basically based on your Azure logged in username, etc., and so on. And it will generate this password as well. So make sure that you make a note of these. And first of all, let me just make a note of this particular URL. So this is currently a Git repository on Azure. Later on, I'll talk about how we can choose to implement continuous integration by using Bitbucket or GitHub, etc., as well, or TFVC as well. But for now, we are using Git, which is the most popular way these days. So make sure that you copy this particular URL to your clipboard, and then we can create a cloned copy of this repository on a local machine. So this is the central or the remote repository, and every developer should create a local or cloned copy of this one on their local machine. So again, you can just use any development IDE like Visual Studio, Eclipse, NetBeans, IntelliJ, etc. and so on. Or you can just use command prompt as well if you want. So for now, again, I'll just use command prompt. And let me make sure that we don't have any extra folders here. Just want to keep things as streamlined as possible. And then here we're going to use get clone command. And then just specify the URL here, which we copied previously from Azure repos section. It will tell you that you don't have access to it, which is usually okay, because once you have clicked this generate credentials, it does take a few seconds before it becomes functional. So just wait it out and then run this command again. This time around, it will show you this prompt and ensure that you enter the credentials. Make a note of the password, paste it here, okay it out. And if you go back to your command prompt, you will see these messages here. It's telling us that currently the cloned copy is currently empty, which makes sense because we have this empty repository. It doesn't contain any file at this point at all. So all developers will want to create a cloned copy of this repository on the local machine. And then here you can have Visual Studio, you can have Eclipse, IntelliJ, NetBeans, whatever IDE you want. You can create your files, check in the changes, and then push the changes to the remote repository. So before I push the changes, let me just go to this file section of this Azure repos section. Currently, we don't have any files at all. And here, let's create a simple file. Later on, I'll definitely create a web application. For now, I just want to show you some of the core basics of Git repository. So we have a simple file, basically. And currently, this file exists only on the local machine. It's actually not even checked into the Git repository. I actually have to make sure that it's under sales folder. Let me just move this file to the sales folder, which is a cloned repository. So we have this test.txt file here. And if you get the list of hidden files and folders, it will show you that we do have this .git because it is a Git repository. And to be more precise, it's a cloned repository. So the remote repository is available on Azure. And this is a cloned copy of that repository on your local development machine. And if you get a Git status, it will tell you that we currently don't have this test.txt file checked into our Git repository. So we should check in the changes. So for that, first of all, we should use this git add command, which will stage this file. So staging the file, you can see it here as well. Use git add to track the changes. So staging the changes or tracking the changes means whatever files are currently not checked into Git repository, they should be marked for getting committed. And if you get status again, so git status is telling us that we do have a file, but currently it is not committed. The changes to be committed, it knows what files are marked or tracked, but they are not currently finalized. They're not really part of the Git repository. So to finalize the changes, we should use git commit command. We should specify some commit message, added a simple test.txt file. It's a simple message so that we can later on find out what's the reason why we made the change and so on. And we do have this file checked in, it's committed, but it's currently available just on this local machine, on this developer machine. So we have to make sure that we submit all the changes which we have on this local developer machine to this remote Azure hosted Git repository, so that other developers who will be cloning this project, they should be able to view the up-to-date changes and so on. So in order to submit the changes from our local machine to Git repository, which is hosted on Azure, we have to use git push. So this will basically submit the changes from our local repository to the remote repository. So from local or a cloned repository to remote repository, the changes have been pushed. Let's verify that we have the files here. So this time around, when you click files, since we do have at least one file, it will not show you the URL the way it was showing you previously. You can still access the URL by clicking just repos, not files. And here we can see that we have one file. And you can choose to view this file here in the web browser as well if you want. By default, it's in a read-only mode. You can choose to click this edit option. You can choose to make some changes here directly in the web browser if you want. It is not the ideal way of making changes. Ideally, we should make changes to the local repository and then push the changes to the remote repository. But still, it's possible to make changes here. So let me make a change here. So let's say we have hello world. I'll commit the changes. Currently, we have just one change made. You can add some message here if you want. And if you use the web browser, by default, it does show you this work item as well. So this work items drop down shows you all the issues or all the tasks that you have created in your backlog. And you can choose to say that whatever change you have made, it corresponds or correlates to a specific issue. And even if you're using Visual Studio or Eclipse or NetBeans or IntelliJ sort of IDEs, even these sort of IDEs will let you connect to this Azure DevOps, and it will let you pick and choose some issue that the current commit corresponds or correlates to and so on. So this way you can basically know, okay, you committed some change, exactly what did you accomplish? So that is the main benefit of assigning some work item to this particular commit operation that you're performing here. So if I commit this change, the remote repository is updated, but our local repository or the cloned repository is not updated automatically. So here, if you want to make sure that this is updated as well, so notice that it's currently just showing us this message hello, whereas in the remote repository, we have this message hello world. So in order to update this local repository, all the developers will want to use get pull command. So pull is the opposite of push. So this will basically connect to our Git repository, which is hosted on Azure. It will download all the changes. So it has identified that this file has been modified. So if you get the contents of this file, now it's showing us the updated message, which is hello world here. So push and pull, they are very, very important concepts. We should use them whenever we have this remote repository and cloned repository involved. Okay, so here we just saw some of the core basics of Git repository. Next, let's see how we can create a simple web application and check in all the files into this remote repository so that we can implement continuous integration and continuous deployment as well. So for that, first of all, let me just delete this particular file. We don't really care for this test.txt file, and ensure that you stage the changes. You can choose to run this get status command. It's telling us that this file should be deleted from the repository. Let's commit the change. Whatever message you want to type in here. The change has been committed just to the local repository, and we should push the changes to the remote repository as well. And then more importantly, we are going to see how to develop a simple web application so that we can later on continuously build it, continuously deploy it as well, and so on. So next, let's create a simple web application. Now, web application wise, you can create any type of application. It can be a simple HTML with JavaScript sort of code. It can be Angular. It can be a Backbone, React sort of application. It can be Java-based application, like it can be Java with Spring Boot. It can be Python. It can be pretty much any type of application. So here, as a case study, I'll take .NET Core as the development framework, and I'll show you how we can create a simple .NET Core-based web application. I'll check in the changes to my Git repository hosted on Azure, and I'll show you how we can continuously build it, continuously deploy it, and so on. So again, as a reminder, you can take pretty much any type of application as a case ready application. So just for now, I'm going to take .NET Core as the case ready development technology. So those guys who are not aware of .NET, so .NET has two flavors now. One is the old flavor, which is also sort of a legacy flavor. It's known as .NET Framework. So .NET Framework just works on Windows-based environment, whereas .NET Core is a cross-platform. It's a future or the modern way of developing .NET-based applications. So .NET Core runs on Windows, it runs on Mac, it runs on Linux, and obviously it runs on all cloud platforms as well. So question, is anyone using .NET Core? If not, what development technology are you guys currently using at work? Is it Java, Node.js, .NET Framework, .NET Core? Thank you, appreciate it. So it seems like it's a mix. Some of you guys are using Java with Spring Boot. Some of you are using just Java, and quite a few are using .NET Core as well. Okay, so .NET Core is very much like Spring Boot these days. So just like those guys who are coming from Spring Boot background, you must have seen that Spring Boot doesn't require deployment to any web server or to any application server, since it has its own built-in server. So likewise, .NET Core has its own built-in server as well, which is based on an open source server called Kestrel. So for .NET, you can create a sample application or a sort of the boilerplate or initial sort of project with just the bare basic sort of or a sort of plain vanilla sort of files. Sort of a boilerplate sort of code can be generated automatically by using .NET New, and you can specify the template you want to use. So for now, I'm going to use MVC, Model View Controller template. You can also create REST services as well by using Web API and so on. So this will basically end up creating a basic project for us. You can customize the project, you can add more web pages, remove them if you want, and so on. And like I mentioned, you can also choose to create a REST service as well if you want, which is also known as .NET Web API. So here we have generated some files and folders that are part of this simple project. And before I do anything else, we have to keep in mind that whatever code we have here, ideally it should be checked into our Git repository so that we can build it. And before you check in the changes to Git repository, since we have a repository here, Git repository, to the Git repository, we should never check in binary files. So files like DLL, .obj should never be checked into the Git repository at all. In other words, we can say that the artifacts, the deployable artifacts, should not be checked into the Git repository. Only the source code should be checked in. So keeping that in mind, ideally we should create a file here. It should be named .getIgnored. The .getIgnored file, there you can specify folders and files that you do not want to check into Git repository at all. So they should be there as part of your folder structure, but they should never be checked into Git repository at all. So create a file, it must have this dot in front of it. So .getIgnored. And here we can specify standard folders. So usually we will end up having a folder named bin. So we do not want to check in the contents of bin folder. Bin will be generated automatically when you perform the build of your application. And likewise, usually we also have this intermediate sort of folder called obj, where we have intermediate build sort of file stored. So these two folders should never be checked in at all. Save the file and verify that we have this git ignored. Ensure that there's no .txt added, since I used Notepad here. So we should not have .txt sort of extension at all. So we have this .get ignored, that's good. And then next we can add these files or track these files, stage these files. currently they are tracked only on our local repository, on the local machine. Next, we can commit the changes. Before that, you can choose to get the status. It's telling us that all these files are tracked. They are not currently committed to the Git repository, but they are being tracked because we have used git add command. Then we can just git commit, specify some message here, created basic MVC app. Okay, so we have committed these files, and let's push these files to our Azure hosted repository. Okay, so once we are done, notice that we do have this obj folder here, which is generated automatically when you use .NET new command. It does create this obj folder by default. But here, in this Azure hosted repository, we do not have obj folder showing up at all because we have this .get ignored. We do have the rest of the files and folders here. They are required. They are the actual source code, basically. Okay, next, before I show you how to implement continuous integration and continuous deployment, for now, let me just show you how we can test or run this application, see how it looks like just on the local machine before we see how to deploy it, how to build it, and how to deploy it to Azure itself. Okay, so for that, you can choose to use .NET build. It will build our application. And usually we also use .NET publish command as well, so that we can sort of consolidate all the deployable artifacts along with all the dependencies and so on in a single folder. This way you'll not have to worry about where your dependencies are located and so on. So .NET build will basically end up creating this folder for us, bin folder, which will contain debug folder, and we can see just a couple of files have been generated here. We have a couple of DLL files basically. You can verify that we have this bin folder here. Let's go to this bin folder, see what other files and folders we have. So we have quite a few subfolders, and here we can see some of the files. Some of them are debug files. We don't care for the debug files. We do have configuration files, .json files. They are the newer way of storing the configuration. Back in the day, we mostly used to rely on web.config, app.config, and so on. Whereas in the modern .NET Core, we mostly rely on .json files. You can also choose to use .NET publish command as well, which basically creates the published version of our deployable artifacts, something that you can just copy paste and expect it to work as it is. So this time around, if you go to this bin folder again, it will show you one more folder, which is publish folder. So this publish folder contains pretty much the same files, but it does contain some more files like dependencies, etc. They're all there. Like we have this www root folder. So it contains all the JavaScript sort of files, etc. and so on. In a nutshell, you can basically take the contents of this publish folder, and you can choose to deploy it to some web server if you want, or if nothing else, you can choose to just containerize it. I'll show you how to containerize our application by using Docker later on. For now, I'm just going to go back to my root folder and just run my application by using .NET run command. So those guys who are coming from Java with Spring Boot sort of background, they must have seen that you can run your Spring Boot applications from command prompt, since Spring Boot has its own built-in server. So likewise, .NET Core also has its own built-in server as well. And by default, it's using this port number 5000. I'll show you how we can make it port number 8080 later on, especially when we see how to containerize our application. And if I view this URL, it will tell us that the certificate that's currently being used by our application is not sort of the professional generated certificate. It's just sort of a test certificate. So the web browser usually complains about it, but that's perfectly okay. We can just accept the risk and continue. So this is basically the sample application, and you can definitely customize it, which I'll do later on when I show you how to perform continuous integration and continuous build. So at this point, we just have a basic .NET Core web application on our local machine, and we are running it just on the local machine. We do have the code checked in into Git repository, hosted on Azure, but currently it is not getting continuously built or continuously deployed. I'll talk about that in detail later on. Before that, let me look at the chat window as well. Okay, so in the chat window, there's a question regarding, is the automated build at check out or check in? So it's always at check in. So there's a question regarding when the automated build will be performed. So I'll show you that in just a bit. But the automated build on Azure will be performed as soon as you check in the changes from your cloned repository into the remote repository. So it's always upon check-in from the cloned repository into remote repository. There's another question regarding so yes, here we are using .NET Core with ASP.NET. So .NET Core is basically the new way of developing .NET applications. Back in the day, we used to have .NET Legacy or .NET Framework, whereas now we have .NET Core. The latest version is .NET Core version 3. And it also actually lets you develop Windows applications as well, like Windows Presentation Foundation applications can also be created in a platform-independent manner. They can run on Windows, Linux, Mac, etc., and so on. And definitely ASP.NET has been platform independent for quite a long while, ever since .NET Core came out. And you can definitely utilize React or other frameworks or client-side frameworks as well if you want. This another question regarding someone is using Jenkins pipeline. So definitely I'll talk about Jenkins as well. You can choose to use Jenkins pipeline as well if you want. Otherwise, Azure has its own native pipeline as well. It's known as Azure pipeline. Okay, so a couple of questions are related to something which we will talk about in detail in just a bit. Like once we have this application, how do we continuously build our application? How do we continuously deploy this application to Azure so that our application is always up to date? It's fully functional at all times. Okay, so basically we just have a basic application running on our local machine at this point. We do have the source code. We do have the source code checked in into this Git repository hosted on Azure, or to be more precise, Azure DevOps as well. Okay, next, let's keep it as it is for now. Let's take a break. We'll resume in about 15 minutes. After the break, I'll talk about how to implement continuous integration and continuous delivery on Azure. So let's resume at 3:15 Eastern Time. Okay, let's continue. So before the break, we discussed how we can set up Azure DevOps organization. Each organization is a collection of multiple projects that are related to each other. It should have at least one project in it. So we have the sales project in our Azure DevOps organization. And then we also talked about boards. We discussed that you can add issues, tasks, epics, etc., and so on. You can set up your Azure hosted repository, which is Git-based repository. Later on, I'll talk about TFVC as well. If you want to set up a continuous integration and continuous deployment with a TFVC or Bitbucket, you can do that as well. I'll talk about that in just a bit. But for now, we have this Git repository on Azure DevOps. Then we create this simple .NET Core web application it's an MVC model view controller based project. You can definitely choose to utilize other type of projects like Spring Boot, or you can have React, etc. and so on if you want. And next, we have to discuss how to set up continuous integration and continuous deployment. So let me go back to the slides just to make sure that we have gone through these things. Okay, so next we have to implement continuous integration. So again, as a reminder, continuous integration means the moment you check in your code to your repository, we should check out the code and we should perform the build. So for that purpose, to implement continuous integration or CI on Azure, there are various options. You can choose to use Jenkins. So those guys who are coming from Jenkins background, you can use Jenkins on Azure as well. You can actually use another option, which is called Theme City. Or you can use Azure native technique. So the native technique provided by Azure is called Azure Pipeline. So our main focus will be on Azure Pipeline, but before that, I'll just briefly talk about Jenkins as well. So Jenkins is available in both open source as well as paid enterprise flavor. Here we will utilize open source flavor on Azure. I'll briefly show you that how we can have Jenkins set up on Azure. It's actually very straightforward. So here on my side, I do have Jenkins set up. Let me also talk about how you can set it up from scratch. So if I go to my portal here, Azure portal, here you have to search for Jenkins. I already have Jenkins pre-set up. So just go to your marketplace, click Jenkins. It will ask you to name your instance and so on. And it does take about 5 to 10 minutes to set it up or to provision it, and before it's up and running. On my side, to speed things up, I've already provisioned it. I just have to start it up. So let me go to my home page, Jenkins. So basically it's set up as a virtual machine, and no, you do not have to connect to the virtual machine at all. You can just type in the URL. It will show you the web-based interface, the same user interface that you're used to. If you have used Jenkins, it will show you the exact same user interface. I just have to start it up. And then here we can see the DNS name or the URL basically. So if you make a note of this particular URL, or let me just open it up in a new tab here. So currently it's still getting started, so it might take a bit of time before it will show us the home page. So let's refresh the page a few more times, and also let's look at the status as well. So if you guys have already used Jenkins, then you'll be able to see that it's actually very straightforward to use Jenkins on Azure as well. It's basically the same user interface. And when you try to access Jenkins URL, although it will show you this login option, but it will give you this error message. It's not exactly an error message. It's basically telling us that due to security reasons, it's not possible to use Jenkins right away like this. Instead, you have to use this SSH. You have to shell into your virtual machine. Then you have to map this Azure hosted Jenkins instance to your local machine IP address, and to your and you can assign it some port number as well if you want. So just make a note of this particular command. Go to your shell and run this particular command as it is. But actually you do have to make one change here, because by default it doesn't contain the actual username, which usually you have to configure at the time of provisioning of the Jenkins instance. So on my side, I've already changed the username. It's not just username, it is Jenkins So when you create your Jenkins instance on Azure, it does ask you to give it some username. So basically, it will map this particular Azure hosted URL to the local machine, and you can specify some port number as well if you want. So when you enter this particular command, it will ask you to enter the password as well. Again, you have to configure the password at the time of provisioning of the Jenkins service on Azure. I've already configured the password. Let me just enter it here. And once you're done running this particular command, it's basically connected to your virtual machine that contains Jenkins instance. But you don't have to do anything else here. You can just open up this particular URL here. So localhost 8080. I do not have Jenkins installed on my local machine. This is just a mapped URL. So we have mapped this local host colon 8080 to Azure hosted Jenkins environment. And if you log in this time around, it will let you log in. I've already configured these credentials as well. So basically, it's a full-blown Jenkins environment, and you're able to use it on your local machine or from pretty much any other machine as well, as long as you have mapped that Azure hosted Jenkins URL to your local machine like this by using SSH command. You'll be able to shell it. You'll be able to connect to it, and you can create your pipelines, your standard jobs, etc., and so on in exactly the same manner, basically. So if you're already used to using Jenkins and you do not want to run Jenkins on your local machine, you want to have it set up on Azure, since you want to migrate all your projects, everything, your entire infrastructure to Azure, then definitely this can be a very useful option. So those guys who haven't used Jenkins in the past will probably end up having another webinar on that. Otherwise, we do have full-blown courses on Jenkins where we'll cover how to create pipelines by using Jenkins. So just know that continuous integration and continuous deployment can be performed by using Jenkins on Azure as well. So let me just stop this virtual machine so that it doesn't cost me too much. So basically, CI/CD can be implemented by using Jenkins, or you can use Azure native technique, which is Azure Pipeline. So Azure Pipeline is part of Azure DevOps. So Azure DevOps, if you go back to the page where we have DevOps, Azure DevOps open, where we have this Git repository, here we have pipelines option as well. So if you go to this pipelines, this is equivalent to Jenkins pipeline concept. So here we can create our first pipeline. So basically our goal is to continuously integrate the changes. When you make any change to your source code, we should check out the code and perform the build. So here it will show us various templates. So notice that we can even connect to Bitbucket as well, or GitHub, or Subversion. So you can have your source control hosted anywhere. It doesn't have to be on Azure. It can be pretty much anywhere. As long as you can access the URL, you can utilize this Azure pipelines to continuously integrate your changes and so on. And obviously, we do have Azure repos Git option as well, which is this repos which we configured previously. So let's use this Azure repos Git. And actually, I forgot to show you that if you go back to the previous page, it will even show you TFVC option as well. You just have to click show more. It will show you TFVC option as well. So here it's recognizing the project which we have in our Azure DevOps. And next, it's showing us various templates, like what type of project you want to build. It will show us various templates. You can click show more. It will show you even more options here. So we have quite a few options available here. We have Gradle, we have Maven. So those guys are coming from Java background. The eyes will most likely light up that we have Gradle, Maven sort of options available. So yes, you can build your Java Spring Boot applications and so on. Node.js is there, so we have tons of options available here. We also have option for building iOS applications as well. For that, we can use Xcode, etc. and so on. So here we have ASP.NET Core-based application. So I'm going to select this option. It will create this pipelines.yaml file. This is where it stores the script that will be responsible for performing the build. So what will happen is that internally it will create Ubuntu-based virtual machine, and in that particular VM it will perform the build. But if you do not want to use this particular technique, you can just use Docker container as well, which I'll show you in just a bit. Basically, it's going to use this script.net build. It's going to build our application, which I showed you on my local machine as well. And I can choose to click the save and run directly here if I want. Let me actually show you this option first before I show you how to use Docker container as well. So if you click save and run, it will run this particular pipeline. So a job is created here. A job is sort of an instance of your pipeline. It's performing the build basically. So whatever instructions you have in that YAML file, currently it's just saying that we have a .NET Core application, so build it. So it will build the application and it will store the artifacts here. You'll be able to see the artifacts in the section later on. So basically, it has performed the build, and we can see the status that it's successful. And you can choose to deploy it right away if you want. But before we perform the deployment, let me actually take this pipeline concept to next level. And you can also see that there's a notification. It's telling us that the build has been completed. You can choose to disable these email notifications if you want. So basically, we want to take this pipeline concept to next level by involving Docker container as well. Now, question is, what is Docker container? Docker container allows us to contain our application along with the dependencies and all the runtime sort of environments that we want. What does that mean? So typically, we have some physical machine. Then usually we have some virtualization software as well. It's not mandatory, but quite a few companies prefer using VMware, Hyper-V, VirtualBox sort of technologies. And then they install some operating system like Windows, Linux, Mac, etc. Then they install various runtime in or various runtimes like a Java runtime or .NET runtime or pretty much any other type of runtime like Perl, Python, etc. and so on. And then usually we install some application server or web server as well. Like in traditional applications, we have like Tomcat, or it can be JBoss, etc. and so on. And then after that, we get to deploy our application and run it on top of some application server or some web server, which relies on some runtime, which runs on top of some operating system, and so on. So typically, we have these things involved. You can choose to use this virtual machine-based technique if you want, but there's a much better, faster technique, which is called Docker container-based technique. So what is Docker container? Docker container is much cheaper option compared to using a virtual machine on Azure, on cloud. You can definitely create a virtual machine on cloud if you want, but it will be very expensive compared to using Docker container. Because in case of virtual machines, you will have to pay for the resources. The RAM, you'll have to say that we need at least 4 GB of RAM or maybe 8 GB or more than that and so on. You will have to pay for the CPUs as well. How many CPUs you're using? 2, 4, 8, whatever. So basically, in case of virtual machines, you have to pay for the virtual machine for as long as it's running. And that can become very costly solution in the long run. Whereas when you use container option basically lets you containerize your application, which means that if you're, let's say, utilizing Spring Boot or .NET Core application, we'll actually not even have to worry about most of these things. Let me actually just write it down here. So if you use Docker container, you'll be able to containerize your application, which will include your application, your runtime, and even your dependencies as well. So your entire application along with dependencies. So dependencies would mean, uh, say you have a Spring Boot application and it relies on, let's say, some jar file or some library, etc., like log4j, or uh, it can be Prometheus or Jaeger or some other logging or tracing sort of library, etc., and so on. So all the dependencies will be contained along with your runtime. And you can actually customize your runtime as well. You can say that you want to utilize Java, you want to use .NET, you want to use Python, you want to use Perl, you want to use Go, which is a language created by Google. So there are lots of other runtimes that you can utilize. You are responsible for the runtime. You install the runtime of your choice. You then containerize your entire application with all the dependencies and so on. So in case of container, this is all you will be responsible for. You will never have to worry about the full-blown operating system. You will not have to be responsible for any virtualization software at all. So you'll basically only be responsible for the containment of your application and the dependencies, all the dependencies, which actually includes your runtimes as well. So basically, containerizing your application will make your application portable, which means that it will work on your local machine, and it will definitely work on all cloud platforms as well, like on Azure, on Amazon AWS, Google Cloud Platform as well, and so on. There's a question in the chat window. So what does it take to install Azure DevOps? You don't need to install any VMware or virtualization software at all on Azure. To use Azure DevOps, you just basically create the organization the way I showed you previously. You just set up your Git repository, or you can just use Bitbucket if you want. And then to set up continuous integration, you can specify what environment you want to use. Like you can install your runtimes. You can specify whether you want to use Java or .NET or Python, etc., and so on, by using this Docker container technology. So Docker container basically lets you create a portable application, something that runs on your local machine for sure, and it should run on your cloud platform as well. So keeping this in mind, let's discuss how we can containerize our application. So this is a fairly short session. So here I can just give you a quick overview, and then I can show you a demo, a functional demo, how it works. But we do have more advanced courses available on Docker, etc., where we cover all these things in great detail, like what exactly Docker is, how do you set it up, etc., and so on. So here I'll show you what exactly Docker container looks like on Azure. So Docker container, again, as a reminder, it's basically a containerized or a containerization solution which contains your application, which means your artifacts, basically, the binaries, basically, along with all the dependencies. So it's a self-contained container which contains everything that's required to run the application. So no other dependency on operating system will be required at all. So it won't care for a specific operating system or some files and folders that are outside of the folder where your artifacts are stored. So it will be a self-contained solution, basically. So keeping this brief concept in mind, let me show you how we can ensure that our .NET Core application is containerized. And for this purpose, let me go to my folder here and ensure that we have a very special file called Docker file. Let me go to my folder, demos, sales. So basically, we need to create a file called Docker file. What exactly is Docker file? Docker file allows us to create an image for a container, which will specify exactly what should be there in that container. So here, We have this syntax. Again, we usually covered all these things in much more detail in the full-blown courses. Here in this short session, I'm just going to give you a quick overview, and then I'll show you how to ensure that our application is containerized and it's deployed. So basically, continuous integration and continuous deployment. That would be the main goal. But to some extent, let me give you a quick overview of this Docker file script as well. So basically, our goal is to build our application, and then later on, we want to deploy our application. So as part of continuous integration, to build our application and ensure that our build is containerized, it's portable, it's self-contained. There should not be any dependency on any other thing at all. Everything should be self-contained basically. So here we are using this from keyword, which will basically allow us to specify some base image, sort of a template basically. So if you want to build a Java application, there's a different template available. You can actually search for all these templates on the official Docker website, which is a search or a hub.docker.com. If you go to this official Docker website, it's the Docker Hub. Here you can see all the base images or the templates. So in case if you're coming from Java Spring Boot background, you want to have Spring Boot pre-installed in the image or the template, you can search for Spring Boot. We have the Spring Boot CI, blah, blah, blah. You can use this particular name. This is a ready-made image. It already contains Spring Boot. If you want a specific version of Spring Boot, you can always specify some label or tag by using colon and then specify the tag or label here. If you, let's say, click on it, it will show you the tags here. So we have various versions available here. So you just have to use colon symbol, and after that, you just specify the versions which you want to use. Likewise, if you want to use, let's say, Python or something else, you can just search for it. It will show you a base image. So all these base images, they already contain some technology of your choice, and you can always customize these even further as well, which I'll do here in this particular script. So in my case, I'm using this .NET Core based image. That's the name of the image. And then once I've pulled this image from hub.docker.com website, which will happen automatically because of this Docker file script, it will switch to this /app folder inside the image. It will create the folder if it doesn't exist. If it exists, it will just switch to it. And then I want to make sure that I copy my project files into this image. So I want to copy my .NET Core application into this particular image so I can perform the build process. So if you just look at this .NET publish command for now, if you recall, we discussed it previously that it basically generates the deployable artifacts for your .NET Core application. In case if you're using Java Spring Boot with, let's say, Gradle, you can use Gradle build command, or you can use Maven install command if you're using Maven. So basically, it will make sure that it utilizes some base image, copies your project files into your image, and performs the build inside that image. And this particular build will be available inside the container based on this image, and we are assigning it a custom name, build environment. And then we are creating another container, which will be the actual container, or actually it's not really a container, it's an image. Image is a blueprint or a template for our container. So it's creating another image here. And this will be the actual image which we will later on deploy to Azure as an up and running website. So this particular image will use ASP.NET as the base image, which will contain just the runtime. ASP.NET Core runtime is there in this one basically. And it's going to copy all the deployable artifacts from this base image, which we have named it build environment. So from build environment, it will copy all the files which we have under /app folder, /out folder, which will contain the deployable artifacts basically. So we want to copy all the files into this custom image. And entry point will basically allow us to run our application. In case of .NET Core, we use .NET command. In case of, let's say, Java, you can use Java -jar, specify the name of your jar file which contains your application. This will basically ensure that your application runs. In case of Node.js, you will use node, specify the file name like index.js or something like that. So basically, entry point is going to run our application. So this last bit, this portion basically, is going to make sure that whatever build we have performed in a different image, it will get the deployable artifacts and it will store them in this image that will be deployed later on. So basically, just make sure that you have a Docker file. Again, as a reminder, Docker by itself can be a fairly huge technology. We do have all the details available in other advanced or full-blown courses. So for now, we have this Docker file. Let me make sure that this Docker file is checked in. Let me go back to this particular command prompt, make sure that we first of all synchronize it with the remote repository by using git pull. Okay, so we have synchronized our local repository, and then make sure that we have added the Docker file. And just like we usually have this git ignore, we can also create Docker ignore as well. So now let me just keep it a bit simple here. Let's commit the changes, -m, specify whatever commit message you want, push the changes to the remote repository. Okay, so basically in this particular commit operation, I've added Docker file script, which will be responsible for creating a Docker image with all the dependencies and or deployable artifacts. So whatever dependencies are required by our deployable artifacts, by our .NET Core application, they will be contained in that image. And here you will also notice that there is continuous integration, which means that each time you check in any change, a build process is performed automatically. Let me actually show you that again. So if I add or make any change here, and you can see that build process got performed here, we have a notification. So basically, it's due to continuous integration. Each time you make any change to your code, it will perform the build process. You'll actually, we will end up adding more commits as well in just a bit. You'll notice that a new build will be performed automatically. We can see that second build got performed. You can see it got performed just 16 seconds ago. Why it got performed? Because I committed the changes to my Git repository. I added Docker file script, which will be responsible for containerizing our build. If you don't want continuous integration, you can choose to disable it or sort of make it manual. For that, you can go to your build and you can edit its option. Otherwise, usually it's the best practice to make sure that it's continuously integrated. So here you can choose to go to this triggers option, and you can say that no, you do not want to continuously perform the build process each time you check in any change to your Git repository. So here in this triggers section, you can choose to disable it if you want. You can choose to schedule it if you want, or you can just choose to make it manual only if you want. So for now, we are going to use the best practice, which is to use continuous integration. So basically, each time you make any change to your code, it will perform the build automatically. Here we have to perform one more thing. We want to make sure that each time this build is performed, it should create the image. Although we have this particular Docker file here, but just due to the presence of this Docker file, it will not create the Docker image with our application and all the dependencies. To ensure that it does create the Docker image, we have to make sure, or in other words, to ensure that this Docker file script is executed, you have to make sure that you go back to your pipelines, and in the pipelines, just edit your pipeline and run a command which should create an up-to-date image which should contain your application and all the dependencies, and it should be deployed to Azure. So for that, we have to go to this pipeline, go to your YAML based script, and we have to run an Azure command line. So search for Azure CLI or just CLI, it will show you Azure CLI. And here it will ask you to specify, okay, you want to create your Docker image, but where exactly you want to save that image. So we have to make sure that the Docker image, which should contain our application and all the dependencies, that should become part of our Azure environment. So in Azure, we have something called Azure Container Registry. So Container Registry is a part of Azure where it registers or stores all Docker images, where each image contains a self-contained application with all the dependencies and so on. So I already have a container registry created here on Azure. I've named it the sales ACR 2020. You can choose to create a new one if you want, but it does take about 5 to 6 minutes. So just to save a bit of time, I've already created this one beforehand. I currently don't have anything deployed here. So just make sure that we have this Azure Container Registry on Azure so that it can contain or store the images. And next, we have to make sure that here we configure this Azure CLI, specify what Azure subscription you want to use, ensure that Azure DevOps can access that subscription so that it can deploy or store the image, Docker image, on Azure. Then here we have to run a script. And let me just hardcode the script here rather than storing it in some shared folder or something like that. And let me open up my script. So basically, we need to run this particular command. This command will run Docker file script for us. What exactly this command will do, let me explain that here. So this command, AZ command, is Azure CLI command. It's going to use ACR argument, which signifies that we need to build our image, or in other words, we want to run this Docker file, which I showed you in this repository as well. So we want to run Docker file, and once it has created the Docker image, it should be named this thing, sales. We are tagging it, we are labeling it with this thing, latest. You can choose to assign some custom version like version 1, version 2, or something like that if you want. And exactly where it should be stored on Azure, we have a custom Azure Container Registry named Sales ACR 2020. That's where we want to save our custom image basically. So this command will execute Docker file script. It will containerize our application. It will have the entire application and all the dependencies in a custom image. We have to basically run this as part of our pipeline so that it creates our Docker image. So click add here. It will generate the code for us automatically, save it. It will get saved as this Azure pipelines.yaml file. And each time you commit any change, it does perform a new build. The build failed. Let's find out why it failed. I might just have to authorize it. You can see the notification is here. It's telling us that the build failed. In most cases, it's because of authorization. We usually have to authorize it. So let's look at the message here. I'm waiting for the build history to show up so that I can find out the reason. It's most likely because of authorization. I just have to click one button there that will authorize this Azure DevOps project so it can connect to our subscription and make some changes to the registry. Let's wait for it to load the history. Oh, there's a question in the chat window. Do I need to keep Java in Docker file? So no, I think I just showed you just to explain that you can have Java as well, but in the committed file, I don't think I have Java. Let me just quickly double check. So yes, it's just using .NET in the actual committed file. Okay, so yes, just like I mentioned, that it's most in most cases it's because the failure is usually because of the lack of authorization. So here we just have to authorize this DevOps pipeline so it can access our Azure container registry, so it can create our image there. So once it's authorized, after that we can test it out by clicking Run New to perform a new build. The build is queued up. Let's look at the status. You can just choose to wait it out or just click on it. It will show you what's exactly is happening here. You can see the status here as well. Okay, so this time around it's much better. That's executing Azure CLI. It's going to create our Docker image and store it in Azure Container Registry. And after that, we'll be able to deploy it. So basically, this is the continuous integration part. So continuous integration means check out the code from Git repository, uh, compile it, generate the packaged output files, the artifacts basically, and make sure that they are available in a Docker image, something that's ready to be deployed. So continuous integration, the output of it should be something that you can deploy. So we are not deploying it at this point. We are just making sure that it's ready to be deployed. So it's currently still running the Docker image. It usually takes up to 3 minutes or so, even for a very simple application. So while it's doing that, let me quickly recap this thing. So basically, this command will execute our Docker file script. It will create an image based on that particular Docker file script. It will name it sales, and it will be available on Azure in this custom Azure container registry. So container registry is a container or a sort of a repository which holds not the source code but Docker images, something that you can deploy. So we're almost done with this continuous integration. Next, I'll talk about continuous deployment. Yes, so this Docker image is the output of this particular continuous integration, and you can deploy this Docker image either to Kubernetes. You can set up Kubernetes on Azure, which is not the scope of this particular session, or you can choose to deploy it as a single container, sort of a standalone container, as part of your web application service, which I'll show you in just a bit. Okay, so it's successful this time around. So we have a Docker image. That's the output of this particular continuous integration part. And to verify that it did generate the image, let's go to the sales ACR Azure Container Registry. You can see that the build is successful. We have this email notification. Here we can go to this repositories. We should have sales here if everything is fine. And I do have TMP sales from one of the previous sessions. So we do have sales here. So that's the one that we care for as far as this particular pipeline is concerned. So basically, continuous integration is happening here. So each time you make any change to your source code, it will trigger the build. It will compile the code, generate a self-contained Docker image, which will contain the application as well as all the dependencies. But question is, how do you view the application, the web application? To view the web application, you need to deploy it. So it's currently not getting deployed right away. So to continuously deploy your application, there are various techniques. Here I'll show you a technique that doesn't require Kubernetes, because Kubernetes is a huge area. Uh, we will cover it in some other session. Otherwise, we have it covered in the full-blown course. In short, Kubernetes is orchestration of multiple Docker images or Docker containers, and it lets you implement fault tolerance like auto failover, load balancing, and so on. So that will be very much out of the scope of this particular session because it's a huge area. So here we are going to use a relatively straightforward technique, which is perfectly fine. Quite a few companies do use this technique to deploy their applications, and it's called web app for containers technique. So web application for containers means you want to deploy a web application and your application is actually in some Docker image. So you want to create a container based on that image and you want to deploy it as a web application. So again, I've already done a bit of homework. I've already created this web app container. It's just an empty container at this point. We don't have any application deployed in this web app. So this is basically just a placeholder sort of thing that can contain some Docker image. So currently I do not have any Docker image here. I do have just the placeholder sort of thing created here, just the object or the resource basically. So here we need to deploy our container, Docker container, or the instance of Docker image, which will be known as container. So how do we continuously deploy our application so we can view the application as well graphically? So for that, just like we have Azure pipelines, likewise we have Azure releases as well. So releases means you want to implement continuous deployment, CD. So to deploy your application, we can click this new pipeline. This is a pipeline for release purpose, deployment purpose, basically. Here, first of all, let's cancel it out and ensure that we specify what exactly you want to deploy. So we want to deploy the build of our application, of this project, basically. And it's available in this, or it's the output of this particular pipeline. So whatever the output of this continuous integration pipeline is, we want to deploy that. And notice that it does let you select TFVC, GitHub as well. So let's click add here. And we want to make sure that deployment should happen automatically as well. So each time you check in any change to your source code, it should perform the build. So CI will happen because of this Azure pipeline. And it should get deployed right away as well. So for now, we want to implement continuous deployment. So the moment the build is performed, it should get deployed right away. So to do that, once you have selected your artifact, we can click this small icon here and implement continuous deployment. And once we have configured continuous deployment, next we can specify where exactly we want to deploy it. So deployment-wise, we have lots of options here, like we even have option to deploy Java-based applications as well and so on. For now, we are just going to use this generic option, which is actually suitable for any type of application. So we're going to use Azure App Service Deployment. Click Apply. Next, we have to configure it, add a task, specify where exactly you want to deploy it, what's the subscription, and what type of application is that? Is that a web app on Windows? It's not. It's actually a web app for containers. So you can use this technique to deploy Java applications, Node.js applications, Python applications, .NET Core applications, and so on. And we already have the Sales Web App 2020. This is the web application sort of placeholder where we can deploy our custom container or the image that will get created as a container here. And here it's asking us to specify the ACR, Azure Container Registry. So where exactly our image is located. So if you recall, I mentioned that all custom images will be stored in some custom container registry. We have named this registry sales ACR. So we need to obtain the login server or just the URL to it and paste it here. This is the registry where we want to deploy our application, or we want to get the Docker image from. So we want to get the image from this one and deploy it into this sales web app. And what's the name of your repository? So I think we named it sales. And what's the version? We have just used latest as the label or the tag. And then once this part is done, make sure that everything is configured. Seems like we missed something here in this pipeline, in this section. Let's just click it again. Here we most likely have to specify the branch, or let me just double check. This part seems to be okay. Then what else is there? Okay, so here we have to specify that we want to continuously deploy our master, the build of the master branch. So that should do. Click save. So basically we have continuous deployment in place now. Then next, let's test it out. Let's manually create a release or manually deploy it. After that, I'll show you automated continuous integration and continuous deployment. So let's click create. It will perform the deployment. Let's look at the status of this deployment. It's currently working. Stage 2 is working. Stage 1 is just get the output of this continuous integration pipeline, and stage 2 is the deployment. So it's working on the deployment. Let's wait for it to complete. Okay, so stage 2 is successfully performed. Next, let's test it out. So notice that previously I used localhost just to show you how the .NET Core application looks like. But now that we have deployed our application to Azure, we should be able to change the URL, use Azure specific URL, and see the output. In fact, you'll be able to see this website on your side as well. So let me give you a URL. So go to your web application. This is the URL. Let me actually paste this URL in the chat window. Usually it doesn't work right away. It does take about 4 to 5 minutes or so to warm up the application. So you'll most likely receive this message on your side as well. To speed things up a little bit, there's a small trick. The trick is usually you can go to your web app and go to this container settings of this web app and just speed up the deployment. So usually it just gets queued, and after that it takes anywhere between 4 to 5 minutes to perform the deployment. So just to speed it up, you can go to your container settings here and just click this save button. So notice that it's using these settings. It's going to pull the image, the custom Docker image from this particular ACR. Our image name is sales. So if you just click save here, it speeds up things a little bit, but even in that case, at times it can still take at least a couple of minutes or so. So we have clicked the save button, and you can also check the status of this particular application, whether it's loading things or not. You can check your log stream. So it's showing us the stream here. So we have to wait for this application to show us messages that yes, it has loaded the image and so on. So let's just give it another couple of minutes or so, and then you'll be able to view this application on your side as well. So currently it's still working on it. And let me click that save button one more time just to speed things up a little bit. Otherwise, usually in real world, obviously you'll never click the save button. You'll just let it do its thing in the background, and it takes about 5 minutes or so. Usually it's slow for the first time, but after that it does speed up once you have deployed your application. Okay, that's more like it. So we can see that the URL that's part of our Azure web app. If you refresh this URL on your side, it's in the chat window. You should be able to see this on your side as well. So can anyone confirm if you're able to see this website on your side? Okay, sounds good. Okay, next, since we have implemented continuous integration and continuous deployment, it means that on day-to-day basis, you just have to focus on writing the source code and just commit the changes to your repository, which means that if I, let's say, modify anything in my source code, let's open up views, home controller, index action. Let's say that we just write some message here like version 2. So I've just changed the heading or the title. Obviously, it will not show up right away. We do have to trigger the build. For that, we just have to use get add, track the changes, get commit, changed it to version 2, get push, and that's it. So basically, you just have to push the changes from your local or cloned repository into your remote repository. And we do have to make sure that everything is synchronized on the local side as well. Like when I create the pipeline or modified the pipeline, it modified the YAML file. So I need to make sure that it's downloaded on the local side before you'll be able to push the changes. Okay, so since we have a continuous integration and continuous deployment, you can choose to look at the status of this continuous integration. It's currently performing the build. Let's look at what's happening. So this is still working. It has taken 11 seconds, 13 seconds. You can see the build rate or the pass rate as well. So one build failed because of authorization that I pointed out previously. So it will take about 2 minutes 43 seconds based on the historical builds. And after performing the build, the output of the build will be, we will have an up-to-date Docker image, which will contain our artifacts, the deployable artifacts, along with all the dependencies. And since we have continuous deployment as well, so deployment will be performed immediately after the build process is performed. In more advanced scenarios, you can choose to involve manual approval process as well, which we cover in the full-blown Azure DevOps courses. So there you can send a notification to some manager or whoever the person will be approving the application, and upon approval, it will perform the deployment. So for now, we are just implementing continuous deployment, which means as soon as the build is performed, it should get deployed right away. So we are waiting for the build to get completed. You can actually look at more details here if you want. So it will show you more messages. At this point, it's performing the, it's building the image basically. It's using Azure CLI command where we are building the Docker image. So let's wait for this one to get completed. So it's 2 minutes 45 seconds. So it should take another 30 seconds or so. After that, it will perform the deployment. So basically, on my side, as a developer, I just wrote some code. I just checked in the changes, pushed the changes to the Git repository, and it has triggered the continuous integration and continuous deployment process automatically. So it's almost done. There's a question in the chat window regarding environments. Oh, good question. So in environments, you can choose to configure environments like dev, test, SIT, UAT, etc., and so on. So you can configure multiple environments. That can be very helpful, especially when you have to later on involve manual approval, so that you can promote the build from one environment to next environment and so on. Okay, so this particular build is taking slightly longer. So let's just, okay, so it's done. It took about 3 minutes, 42 seconds. Now, if you go to releases, it should have triggered the continuous deployment. So deployment was apparently fast. So let's go back to our website, refresh the page. So here we can see version 2 is showing up. So if you guys refresh it on your side as well, it will most likely show you version 2. So basically, we just wrote the code, we modified the source code, checked in the changes, it triggered the continuous integration pipeline and continuous deployment pipeline. So that's basically CI/CD. And definitely, Azure DevOps does support various repositories. Like you do not have to set up Git repository on Azure DevOps if you don't want to. You can connect it to TFVC. I showed you one of the options or one of the steps where it asks you to specify where your source code is located. You can specify Bitbucket, and you can also definitely use mono repository as well if you want. There's a question in the chat window regarding how is Azure performance in real multi-dependency application. So like you saw that even for a very simple application, it took close to 3 minutes to perform the build. So definitely when you have more complex real world sort of applications, it can take longer time, like 15 to 20 minutes, depending on how complex your application is. So it is automated. It's all on cloud. So time-wise, it's not as fast as running it on your on-premises sort of environment. But again, it depends on how complex your application is, how much resources you have on your machine, and so on. And there's another question regarding billing. So billing-wise, yes, it is based on the usage. So how frequently you're performing the build, what's the size of your build. So when it performs a build, how much CPU got used internally on Microsoft end. But usually that's not a very big factor here. The bigger factor here is the size of your repository and Docker containers, definitely. So the storage that you're consuming. So that is basically Azure DevOps in a nutshell. So any further questions regarding Azure DevOps? And as a reminder, you saw that DevOps is the end-to-end process which lets you plan your project, continuously integrate your project, continuously deploy your project, etc., and so on. There are more advanced things as well, like how you can monitor your project. For that, you can use various things such as application insights, etc., and so on. And you can also get feedback, etc., and so on. So there are lots of other advanced things as well. We do have a full-blown courses on Azure DevOps where we cover more advanced concepts like how to deploy your application by using blue-green deployment. So if you guys get a chance, just Google for blue-green deployment concept. Here on Azure, it's called slots. So you can configure multiple slots. So basically in blue-green deployment, you switch the roles from dev to prod. And whatever the new prod is, later on you start writing or modifying the code, and it becomes your new dev environment. And your previous dev environment becomes your new prod environment. So basically toggle the roles of your development and production environment for rapid deployment of your applications. So there are lots of more advanced concepts available as well and so on. There's a question regarding security. So security-wise, definitely you can add user accounts here. You can assign them permissions, who can do what, who can check in the code, who can perform the build, who can perform the deployment, etc. and so on. So definitely you can configure these. And definitely logging can also be implemented as well. So logging wise, if nothing else, for your web application itself, you can use log stream. Otherwise, you can use more options like application insights, alerts, metrics can be utilized as well and so on. Okay. Any further questions? And I'll also share the PDF file with you guys. We will also have a recorded video of this session uploaded on web site as well. So in the chat window, you can see a link to the slides. And if there's any further question, you guys can ask. Otherwise, there's one small formality. So if you guys could please go to this website. The link is in the chat window. So basically, there are a couple of links. The first link is to the PDF file. And the second link, web8solutions.com/eval, or actually I've missed .com. So if you guys could please follow this last link and just enter this class code there and then select daily. And yes, we will have the video uploaded as well. So you'll be able to access video by going to Web8 Solutions website. So you just have to go to webinar section and you should be able to see it there. But it does take about a week or so for us to process the video and upload the file. Okay, so is everyone able to access the last link, the eval link? So there, please enter the code number and then just select daily. Okay, so thank you very much, guys. It was a pleasure to be here with you for this session. And just as a reminder, if anyone is interested in the full-blown Azure DevOps courses, we have a 5-day course on Azure DevOps. It covers all or most of the important concepts that we have on Azure DevOps. It's actually also geared towards Microsoft certification as well. It's AZ 400. Otherwise, if you're looking for non-Azure based DevOps courses, we do have various offerings available for that as well. Like if you want to use Kubernetes without Azure, along with Docker containers, etc., and so on, we have courses on these as well.